So we will be talking about industrial air pollution. Electric vehicle production is known to emit a lot of air pollution because of the mining associated with the industry. For example, there is a lot of lithium, cobalt, and aluminum mining that is necessary to produce the cathode and anode. This mining produces a lot more particulate matter, nitrogen oxides, and sulfur dioxides than the production of fuel powered vehicles. Therefore, one disadvantage of the electric vehicle production is the emissions that they produce. And a lot of these emissions that they produce are because of their dependence on energy, fossil fuels, and toxic pollutants that they release either from the mining or from other phases. This all leads to an environmental burden and greenhouse gas emissions, which is detrimental to the environment and contributes to air pollution. Most of the lithium is mined from the Lithium Triangle in South America. It consists of countries of Argentina, Bolivia, and Chile. The lithium in Bolivia is known to be a lot less pure, so a lot more energy has to be consumed to refine that lithium. Also, when the mining occurs, it leaves the region depleted from its resources, as seen in Figure 2, and it often drains the regions from their water resources. There's also pollution outside of the production phase. So before, when electric vehicles had lead batteries, they were releasing a lot more lead than gasoline powered vehicles. So thanks to the Clean Air Act, lead gasoline and lead batteries were banned. So this minimized the air pollution. However, when the vehicle's batteries are recycled, there's air pollution associated with this phase because the battery can either be burned or it can be dunked in acid, and a lot of these acids can be detrimental. Um, so it also depends on the electricity that is used for charging these vehicles. If the electricity is derived from natural gas, then that electricity leads to less greenhouse gas emissions. So possible improvements for the electric vehicle industry are to have shared electric vehicles to minimize the energy consumption of like multiple people having to charge their vehicles. We can develop photovoltaic cells, which input solar energy into chemical energy to charge our cars. And we can also develop better recycling practices, such as finding naturally derived acids to recycle these batteries. And now I'll be moving on to Noah.
Okay, so usually when we associate space exploration, it's usually positive. It's seen as like the future of humanity. But along with these positives, it's very important to remember some of the negatives it brings. Specifically, if we think about just carbon emissions, one rocket launch produces up to 300 tons of carbon dioxide into the upper atmosphere where it remains for years. Due to this fact, the amount of rocket launches continues to rise. It's very worrying. Plus, these numbers are only going up with the future plans of sending a man to Mars and growth in commercialized space travel. Referring to commercialized space travel, the carbon footprint of launching yourself into space in one rocket is close to about 100 times higher than if you were just to take a long distance flight. And commercialized space travel seems like the future of space travel, which is very worrying. Some solutions to this: EPA are working on amending the Clear Air Act to, I guess, have more control over rocket launches, so it's more clear air, more sustainable launches. Somewhat how they do it with the planes today. Private companies are also pouring in billions of dollars just to make their technologies cleaner. And if we go to the next slide, currently our orbit is also being polluted. There's currently 21,000 or over 21,000 man-made objects orbiting Earth at the moment, over 10 centimeters, and only less than 5% of them are actually operational. Currently, there's also 10 billion to 1 quadrillion pieces that are smaller than this. Scientists are predicting an event known as the cascade effect. In summary, once the Earth's orbit reaches a critical mass in the form of space debris clutter, it is only a matter of time before this orbital debris begins to collide. Some solutions to this is following SpaceX's plan of autonomous rocket landings, where rockets land themselves. We are dumping more garbage into our orbit. However, sadly, there is no clear, safe plan for eliminating clutter. I am in no way against space travel. I just believe we need to be more careful and understanding of how it can hurt us as well. With that, I'm going to pass it to Radeen.
So I'll be talking about the overall impacts of electric versus internal combustion engine vehicles on the environment, and specifically with air pollution. So to start off with the infrastructure of both fuel sources, gasoline and diesel fuel sources not only exist for internal combustion engines, but they're quite evolvable and they're quite repairable in the sense that we're not having to reconstruct the systems every 5 to 10 years for updates with how we fuel our cars. At the same token, infrastructures for EV charging are constantly being constructed and reconstructed, redesigned with updates. And that comes with its own carbon footprint, the constant restructuring, the reconstruction of these stations. Not only that, these stations currently are planning on expanding with the use of fossil fuels, natural gas and coal as the source of electricity for these charging stations. So not only do the EV charging stations already put a strain on overloaded existing systems like our natural gas and coal, but an increase in such without an update in the way we provide those stations electricity is just going to make the topic of air pollution worse. When it comes to assembly, EV production emits almost twice the amount of greenhouse gases compared to the construction of a typical gasoline or diesel powered vehicle, and that is just due to the batteries in themselves. They require a lot of special metals, which require mining all across the globe. Now, while the assembly of the vehicle is significantly worse for the environment because of the batteries, the total carbon footprint offsets over the expected lifetime just because EVs don't have tailpipe emissions. Off to the next slide. Awesome. So another impact obviously is just operation. EVs and internal combustion's carbon footprint does actually vary due to the location. For example, in China, it's found that EVs actually produce more CO2 emissions compared to internal combustion engine vehicles of the area, while that does not follow in Germany, USA, and Japan. And that is just due to the type of electricity and the way China produces electricity in that region, also due to the type of driving being done in the region and the types of temperatures. When it comes to recycling the components, recycling EV components like lithium-ion batteries is much more involved and it's still being developed. It requires a lot of time, money, labor, and the physical material separation that is required to recycle an EV battery comes with its own carbon footprint. It does not help that approximately 5% of all expired EV batteries end up being recycled back into batteries. That is absolutely something we can improve. And while we're having to constantly update the way we recycle EV batteries, the recycling of internal combustion engine components, like the materials involved in making engines and transmissions, et cetera, already exist. And with that, I will move on.
Hello, today I'm going to be talking about the environmental impact of NFTs and cryptocurrency. So NFTs and cryptocurrency are new technological developments which allow for the trading of digital currency and assets. And this happens independent from banks and institutions. NFTs are non-fungible tokens, and they're usually crypto art, which can be bought and sold with a cryptocurrency called Ethereum along a blockchain. Approximately 1.51 kilograms of CO2 emissions are released into the atmosphere for $1 of transaction fees. So cryptocurrency is created through the process of mining, which is when highly advanced computers answer incredibly complicated math questions. And different mining farms compete with each other to be able to solve these problems in the fastest amount of time. When it comes to Ethereum, which is the cryptocurrency used to trade NFTs, the amount of energy consumed when mining equals that of the Republic of Ireland. In order for a piece of art to become an NFT, it first needs to be minted along a blockchain, which is a permanent digital ledger that marks who owns a digital asset. So in terms of solutions for NFTs and cryptocurrency, you could easily transfer over to a proof of stake system, which basically, instead of every mining farm competing to solve the complicated math problem, only one miner solves the math problem, and that reduces the amount of environmental impact of the network by 99%. Another solution you can do is to move transactions off chain onto what's called layer 2. And that consumes a much less energy than handling transactions on the main chain. You can also purchase carbon offsets, which could be investments in renewable energy or planting trees, place regulations on mining through government, invest in renewable energy, and target countries for mining which are sustainable. If you go on to the next slide, you can see a map which shows the most sustainable countries for cryptocurrency mining. Those are currently Germany and Denmark. And the countries that we mine in now, Venezuela, Libya, Iran, and Malaysia, are some of the worst countries to mine in terms of sustainability. You can see that sustainability is based on all of the factors on the left and in the table 1 at the top. With that, that is the end of our presentation. Thank you for listening.